Hey y'all, I'm Ryan. Welcome to my channel. I hope we're all relatively caffeinated because in this video we're going to be going over this weirdo workflow that I made, showcasing how you can use my node suite to get some abstract audio reactivity in COMFYUI. The original video that I made used copyrighted music, so I've put it in a separate video if you want to check it out. It includes not only Kamala, but also our humble Republican candidate and a special guest. So check that out. I'll also link to the workflow and the GitHub and all that in the description. All right, let's start at the beginning. So we load the audio and separate the audio into its component parts and then extract the audio feature from the drums specifically. And these features, I'll link to the tutorial for the Flex feature system, and it's how the nodes allow you to make audio reactive stuff of all kinds. But like I always do, I want to stress that while audio is popular and I enjoy using it, you can swap out any feature source to create the same sort of reactivity in your workflows. So instead of audio, we could use motion from another video, brightness, color, time, proximity, depth, etc. So this is a powerful audio reactivity node suite, but what makes it exceptional and stand out among all the other audio reactive stuff available to you is that you can swap it out for any feature source, not just audio, and it will work the same way. All right. So we've extracted the audio, the drums specifically, and we've created a feature from those drums. And here's what the drums sound like. So I didn't want all of that to come through. I wanted it mostly just the kick and snare and remove some of that noise. So we've done that here. I also didn't want it to be too strong, so I'll go over the relevant settings, the ones that I changed. We set the ceiling here to 0.25. That means the maximum feature value is 0.25 because we don't want it to be too strong. The feature threshold removes all that noise I was just talking about, basically isolating the kick and snare for us. So anything below 0.2 was ignored. And then finally, I've inverted the output because I don't actually want it to be on the kick and snare. I want it to be in between the kick and snare. So we've convert the waveform. I don't know if I mentioned this, but this is a beta. This is new and it's in beta. I will improve it going forward. I'll label it properly as beta as well. So we take the waveform and we convert it to a mask so that we can use this mask morph. And we're using our feature that we've just manipulated to control the morphing of this mask. We're dilating it, so it's getting a little bit thicker for additional rub. And then, so after we morph it, according to the drums, we convert it back to an image so we can use it later. So here's the original waveform output, and here is the manipulated one. Just for additional flavor. All right, moving on. We use that waveform as the latent input for the sampler, which is what gives us sort of an interesting effect. This is important for later. You'll notice that I've put nothing except the trigger word in the text prompt. All right, shout out to my boy A-Cats for for this animate diff setup here. There's going to be an interesting video with his integration with my Notepad coming soon. Alrighty, to the first sampler, we've got our latent of that waveform, and what's sort of important here is the denoise value. To let you know what the denoise value will do, if we set this to 0, the output would be literally the waveform. If we set it to 1, it's the most creative that the model can get. So the sweet spot right here, and you get vastly different outputs. So for example, like this. So now it's time to add Kamala into the mix, or Kamala, whatever. I don't know what it is. So we add that, we're now going to add more conditioning. So from now on, the conditioning will include this text, and we do that by combining it with the conditioning, the original conditioning that had just the trigger word. This probably wasn't necessary, an accident. We have an IP adapter face ID, so we basically slam the whatever face, we slam the face into the model. So it's really going to be looking for that, where it can put that face. Here you'll see that I've changed the denoise just a little bit lower. It seems like, I don't know why, but it seems like 0.83 is like a spot. Like if you go above 0.83, it's wildly strong, and if you go below 0.83, it's not so strong. But you can get vastly different outputs here. Let me show you. This is all from manipulating the denoise. You get just really different looking stuff. Okay, and then finally we upscale the latent and do a very low denoise value, because I want to retain much of this input, but just like make it smoother, better looking. It's sort of like just upscaling it. So we upscale the latent and sample it again with a really low, relatively low denoise value. All right, that basically covers it. It's a funny one. I liked doing this. Figured I'd share it with you guys. Please like, share, subscribe, whatever. Check out the GitHub, give me a star, Civic profile, give me a follow, blah, 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 blah. I've been Ryan. Thanks for watching. Bye-bye.